send you the file. The reason I'm not hosting this file in a source repository is because I want you to start from scratch. Because if you git clone, you will have the Git file on your local computer, so I won't do that. So if I want to share it here, perfect. So I will send this IPython notebook, and please open up that file in your, download it to your local computer, and then anyone is not familiar with Jupyter notebooks? Anyone who doesn't have Jupyter notebook on their laptop? Okay, everyone has it? Beautiful. Let me do it again because I assume that, so it is considered as a JSON object. If you have any problem with downloading that, I'm attaching a zip version of the file. Anyone has it? Beautiful. So for those, if there's anyone who's shy to say that the Jupyter environment is not ready on their laptop, if you want to host it, you can of course host it to any hosted Jupyter environment, but also you can use notebooks.azure.com. You can basically upload this into notebooks.azure.com. This is like a free environment to basically develop your code on a Jupyter notebook. You can log in with your Azure subscription that you created, and then you'll be good to go. Awesome. So everyone is ready to start? So actually, yes. Yeah, sure. So do you have Jupyter Notebook installed on the laptop? Perfect. So if you go to a terminal, you have Mac or Windows? Okay, perfect. So if you go to the terminal, doesn't matter really. So Mac or Windows is the same. So if you go to the terminal and then type Jupyter Notebook within that environment, so you will basically see a prompt which tells you that the notebook is available in a particular address. Have you seen the prompt, the result? If the TAs can help, Jake or Werner, that would be amazing. That gentleman at the back. Yes, please. I know that, yeah. You could do that, but now you cannot? No, yeah, exactly. So you created a Conda environment? Yeah. So if you have created a Conda environment that doesn't have any impact on the previous installation, so that's the reason I wanted to separate that. So probably there's a problem with your installation. So that's okay. So you can... How it doesn't work. So what I need to do? So yeah, so you can go, again, I cannot really like troubleshoot your laptop's problem, but you can go to the notebooks.azure.com. You can host your notebook there, and they can basically follow the steps there. Awesome.
Yeah, in my Azure environment it doesn't work. In my base environment it does work.
So it's okay. Run it on your base environment.
Yeah. I'm just saying it's like a common issue.
Yeah. Did you install Jupyter in Azure environment?
So, no problem. No, I'm good. Yeah. So you can exit from this. Exit. So just deactivate Conda.
I have it open.
Okay, perfect.
But I just doesn't work in the Azure.
No, because you need to install the package, right?
So it's not installed in the Azure?
No. That's only the SDK to talk with Azure. That's not the Azure installation.
Yes, but so the Azure ML environment cannot run.
So because within the Azure environment, you didn't install Jupyter, right?
Oh, I see.
Yeah. So are you good now?
Probably,
So let me see. So open up your terminal.
yeah, I used to, every time I just wrote Jupyter notebook and it worked.
Okay. So do you have Conda or pip? So you can do pip install Jupyter now, and then it will be good. Okay. I think the problem is solved. Beautiful. So now I'm opening up my notebook. And again, the Azure SDK that you install is just another package. It's not basically like full environment. It's like another package to only talk to Azure. So if you want to have other Conda installation packages, you need to install those as well as like a secondary basically thing. And Jupyter is also another thing that you need to install on your environment to be able to run. If you are running Conda, which is mini Conda, if you're running on a Conda, you basically have the Jupyter by default. So are we good to continue? Perfect. So in order to just go through this, I'm gonna split my
I'm picking people up. If you have to speak, please speak as low as possible. The mic is picking you up.
Thank you. All right, so part of the screen is basically you can open up VS Code, which you installed, or any IDE that you have installed, like PyCharm or other stuff if you want. And I basically have this open up these three because I want to show you a couple of things. So now I basically open up my Jupyter notebook on my local computer. So Jupyter notebook, and then open up that IPython notebook. So when it basically kick off something, kick off a Jupyter notebook, you will basically get a .ipython notebook folder, which has all of the some of the configurations files in it. And then like these three are basically to open up all of these. Code star basically opens up the VS Code from your local directory, the directory that you're basically in, and others like starts the terminal and also starts the Windows Explorer. I'm not sure exactly what are the equivalents in Mac, but they will be similar. So right now, when I basically run ls.ah or lah, you will basically see the list of everything which is within that folder, right? The first thing that you need to do basically when you basically want to set up your Git environment to provide your username and email, please change it to your username and email information, name and email that you use basically to log into your GitHub. Please provide those. And then we're going to start from here. So the first command is basically to run Git Init. So when you run Git Init, the first thing you will notice is basically you will see the .git appears here. And also in your source controller, you will see that a master also appears here. And also if you have a type of source controller functionality within your IDE, like VS Code or Pachyderm, you will basically see a 1 appear beside this icon. And this icon is basically showing you everything you can do within basically a source controller, a Git-based source controller, or GitHub here. or anything else. But the interesting part is that everything right now is on my local computer. I don't have any GitHub repository, nothing. Everything is my local computer, right? So when I click on head, I basically see something like master. There is a file within .git folder. Again, if you do not see that on your local computer, on Macs, dots are hidden file folders, so you may not be able to see them. So within that, you will see a file called head. So within head, you will see a reference which is pointing to master. Later on, after we get to the branching, you will understand what this head is really referring to. But just in short, is basically referring to the current branch and the latest commits, like the most recent code basically within your branch. So when I run get a status, I be able to see that it's telling me there are two things which are not tracked. One is a folder, and the other one is Git tutorial. So when I go back to this picture, you will see that when it says something is on track, it means you have some file within your working workspace, which is your folders, which is changed, but is not staged within the indexing environment. So it's telling you that you need to index these two to be able to keep track of the history and version that. Again, that may sound like very trivial for many of those who are actually have worked with Git, so I apologize for that. I need to go through the basics first. Just want to make sure everyone is on the same page. So just for the reason of this tutorial, I will instruct Git to ignore anything which is currently within my folder. In order to do that, I need to create a file called .gitignore, and within that I can provide the names of the files or the folders that I want to basically ignore, and I can also provide like some regex like star.csv or any kind of regex to basically help Git to understand what files or folders to ignore. Like I'm basically adding the folder, which is anything which is under .ipython, and also this actual IPython notebook. And the reason is because I want to change this, and this looks like basically a source to make modification on my actual code environment. So I'm actually adding these two to the ignore, and what it does, it basically creates a file here, .ignore. Now if I run the status again, you see, I don't see those tracks anymore. I only see .ignore, right? Those are completely ignored because it doesn't want to basically track. So in order to start tracking, you need to basically stage a couple of things. But before that, I want to create a couple of files. I want to just add a couple of files. I want to add a training.py, and within training.py, I'm just writing a print statement, simple print statement. And again, if I run status, I will see there is another file which is again untracked within this directory, within this Git local Git repository. So again, it means that I'm not tracking this anymore. In order to start tracking things, you can call something, a command called Git Add. And what does Git Add do? It basically, it will stage things from working directory in the indexing environment. So it means that you basically can add this, and then once you add it, you see that this training.py is now part of a different message, and still we have git init.ignore under the par, which tells me that is not tracked, right? So it means that I only tracked training.py, but not the .git init, right? So now the training.py is now part of my staging environment. Now if I want to add it to the local repository, I need to call Git Commit. And when I just type Git Commit on the on my local repository, you see that we only are left with .ignore. So it means that now the changes that we've made to the training.py is staged and now tracked within the and then committed to the local repository. So we have the changes made are tracked and we have the history there. Now I start doing more modification. I add another file, reference.py, and then I want to add that to the tracking environment. In order to instead of providing a file name for the add command, you can also provide dot, which means I want to track everything which is available within my local directory, and also mentioned, and also it still considers the dot ignore. It will basically add everything which is there, which now adds dot ignore, and also reference.py. So now these two are tracked and committed to the local repository. So I have now my local environment, which are these three are now working. So I'm basically have the local working environment, the Git environment, the staging environment, and also the local repository. Perfect. So when I hit status, I see that nothing to commit, and also it tells me that I'm on the master branch. We'll get to the master branching part in a minute. So now I'm still continuing to do some more changes, and also at the same time, I commit for any new change. And I see there are 5 commits here. This is like a bash script I'm running within my notebook environment, which is similar to Linux bash commands, or you can basically copy and paste it within your Mac terminal. It actually works. Similarly, I'm basically modifying some more parts within the .training file. And now, when I made all of these modifications, I basically can see all of the logs. Again, this is important because you want to basically be able to track all of the changes you made. Within Git, every time you hit commit, is basically keeping the entire application within the new commit command. So it means that every time we have the entire history of the application and entire files. It also does have some kind of optimization mechanism, so it doesn't if you have 50 files, if you change another file, it doesn't it doesn't save 101 file. It will keep only 50, and also only the file which is changed at every single step. All right. So I'm gonna skip these parts, which is okay, which is not really important. Now go to your GitHub account. Anyone who doesn't have a GitHub account here? Beautiful. So if you're in your GitHub account, please create a public repo. You can also still create a private repo for free. So when you log into your GitHub, you can basically hit on new and then create that. So just provide a name to this, and then we'll get back to this. I have created one for myself for this one. So let me create for myself like Git course class. So I just pick the public and then hit create. So when you create this, it basically gives you an empty repository, remote repository for you to basically host your code. So what I want to do, I want to connect my local repository to a remote repository so I can save my file in a remote repository. So I already have the code here, so you need to change it to change this URL to something that you have just created, the local account, and also the GitHub repository name. And at the end, you have to have .git. If you don't provide it, it doesn't understand that you're referring to a GitHub repository. And then you hit Shift Enter. So when you basically create that, it now have connected your local repository to a remote repository. Now the next command, what it does, it basically pushes all of the changes you have made to a remote repository. So you can use any name, again, going back to the previous command, in the git remote add, you can use any name instead of the upstream. In the suggestion uses, it tells you to use origin, but a person use upstream for myself to remind myself that this is a connection to an upstream repository, because origin sometimes doesn't really mean anything. And also, when I hit push, I basically provide what repository I'm referring to, and then I provide a particular branch. We'll get to that a little bit later if you're not familiar with branch, but it's basically
How many branches can I have?
yeah, unlimited. Yeah. All right. So now we go to something which you can use basically to track your activities. We can also use this to track your teammates' activities when you're basically working on your capstone project, creating issues on GitHub, and issues means tasks. This goes to the not always issues are issues. Sometimes issues are basically tasks, bugs, new features, and etc. So basically, once you go to your GitHub repository, you see that. So again, when I refresh my page, okay, I found something a little bit buggy about running bash scripts within notebooks. So it doesn't push successfully. So in order to push it, so just copy paste this command into your terminal, and then it will be good. So for terminal, I'm using like my VS Code. So again, VS Code, you can have like multiple terminals. Like by clicking this one, you can basically add new terminals here. And then if you see that this notebook is getting stuck on running a particular command, you see this on forever, it doesn't turn off, you can basically hit kernel and shut down or restart. Because sometimes stop doesn't work. You basically hard restart that. It means it just turns off your Python interpreter and then kicks off a new one. All right. So when I hit push, after the push, I should be able to see these new files within my remote repository. So what I did, I basically copied all of the files into remote repository with all of the history of the changes that I made on my local computer. So that's actually very helpful. So it means that if someone else copies this in their local computer, they will see all of the histories and all the changes, which is unique. All right. So now I go to something called issues. So within issues, you can basically create tasks. So there are a couple of places you can do that. There is Jira, which is another issue tracker, which is like known as issue tracker, but you can think of it as a task tracker, or Azure DevOps boards, which is again another issue tracker. We can use like task and milestone assigned to the people. So similarly, I want to do it here. I want to create a new issue. I name it like add hyperparameter tuning. I have so many typos, but no, that's okay. And basically, I can provide some text. Something good about this is that I can basically provide some checkbox. I will show you what it works like task 1. I provide some tasks. 2 and 3. So when I create this, I basically, okay, I forgot to add this. Okay, so now I do have like a task which basically I can see like there's a multi-task within the issue. So the reason I'm basically having like creating tasks is I can track how many of them are resolved. Like if I like click two of them, if I go back to the issue, I see that 2 out of 3 is basically done. So again, you can use this for your capstone project to follow and assign the task to your team members within the GitHub repository that you share within your team members. But the reason I actually created this is not just to show you like there's a cool feature on GitHub, but basically I want to connect a Git commit to an issue. And I'll basically want to keep track of that when I commit. The reason is every time you're committing something, you have to have a task which is backed for that commit. You should not really just play with the code for no reason, right? It should be a very coarse-grained task or at least a high-level task assigned to that issue. So you see that there is a number assigned to this, and mostly it starts with 1, but not always. Sometimes surprises start with 100 or 10. I don't know why, but this time I'm getting 1. I'm the lucky person today. So like when I go back to the code, let's say I want to make a new change to my source code. Just change something your source code. Testing issues. And then when I basically start staging that and committing that, I can have a way to basically assign this commit to this particular task, to this particular issue. The way you would do that is basically very simple. So again, you need to do add. You want to stage that first. And then you would be able to do git commit. Within git commit, you have to provide a text, right? Why you're basically committing that. I'm just providing this, testing the issues. And I provide number 1 at the end. So when I do that, basically I'm able to connect this commit to that issue. Now when I hit push, it again sends the changes to the remote repository, right? So when I go back to the issue and refresh, I see that this new commit that I made is now assigned to this issue, right? So there's also another reason to use issues here and also connect it to the Git is because sometimes after an issue is done, you want to basically close it with a particular commit. And that's very important also because you want to know why you close that and again have a lineage back to the actual commit as part of the reproducibility. Again, I would add another change to my code. Closing the issue, or like completing the issue. And now, when I basically do the git add again to stage it first, then git commit to basically like commit it to my source repository. Here, again, I would have to say that the resolved number 1. Git is sensitive for a couple of keywords. Resolve is one of them. And what it does is basically will close that when I push it to the remote repository. So when I hit push, again, when I go back to my issue tracker, I will be able to see that this is actually closed, right? So again, everything needs to be controlled through the code because we want to keep the lineage, right? Everything has to have a backup from the code and changes we made to be able to track and see. This is very important for the operations team because they will see your lineage to be able to understand what has happened within the code and being able to like trust the actual model or not. That's very helpful. Many basically check these. Of course, depends on the complexity and pickiness of the teams for sure. All right, so I bring this back again to here, and then